This right here, as a side note, we'll come back to in a moment, is the change in P. Just because I got final minus initial, that's just change. What I'm going to do now is I'm going to get all the initials on one side, all the finals on the other. So I'm going to bring that over to the left and this over to the right. So since that's negative, I add it. Since that's negative, I add it. So I got P final A plus P final B equals P initial A plus P initial B. So whatever this P is, my total initially is equal to my total at the end. Whenever in physics you have a sum of something that's equal at the beginning and equal at the end, this in physics is known as conservation. So P initial is equal to P final. So whatever P is, it is conserved. This P is momentum. Momentum. And this is a simplified version of the derivation for conservation of momentum. So whatever momentum I have before a collision is the same amount of momentum I have after a collision. And that is what you'll be exploring in the lab today. One other side note before we sort of transition. On the left-hand side here, I have force times time, and basically, it's force times time until I get to here. This is the point when I switch sides. Things move over. This force times time is equal to the change in momentum. Force times time has a special name. In my other obscure loop, there's a perfume commercial in the 70s. When someone suddenly buys you flowers, that is called a gift. Not suddenly, but you know, it's as if you weren't watching TV commercials in the 70s. There is in the Chapter 6 commentary, I think I have a link to the YouTube the commercial. It's called Impulse.
Oh, you said somebody just buys you one?
Yeah, if someone suddenly buys you flowers, that's called Impulse.
Spontaneous?
Hey, you know what?
A gift?
You should find out the people who made that commercial and nitpick with them.
Oh. Well,
and then let me know what goes. I'm curious if you actually track them down.
No, but they did, okay, I get it. They did act on impulse.
So anyway, impulse is not just when someone suddenly buys you flowers or a perfume that I think probably no longer is manufactured. It's also equal to the change of momentum or force times time. Yeah. On that note, just so you don't get too excited, we'll just take about 10 minutes to sort of relax. We're going to meet over in the other room, and we'll set up, we're doing the momentum lab, which will be potentially even more exciting than the derivation.